Hi everyone. In this video, we are going to look at annuity. First of all, what is an annuity? We can identify an annuity by looking for these two characteristics. First, no matter you have a deposit or payment or withdraw, as long as it is periodic, it's not one-time thing. You have to do it repeatedly. And secondly, the amount of your deposit or withdraw has to be fixed, have to be same amount all the time. So periodic, repeating, and fixed amount. And if you have these two characteristics, and that is an annuity. And both annuity account and compound interest account are compounding account. They're both compounding. The difference between regular compounding interest account and the annuity account is about whether your deposit is periodic, repeating one, or one lump sum deposit. And that makes them different. In a regular compounded interest account, you just make a one lump sum deposit at the beginning, let it compounding without any more deposit in the future. But in an annuity account, you make a repeating deposit periodically with the same amount. There are two different kind of annuities, and in terms of annuity problems, one is regarding the future value of your annuity account. So this video, we just focus on that part. In the next video, we focus on the present value of annuity problems. So this is the first video. Now let's take a look at the formula to calculate the future value of an annuity. Now, this is just a description of how you calculate the future value of annuity. I just copy and paste from your homework page on the Blackboard. And this is a formula that I translate this description into, so that after you read this, you can just look at this formula when you do the calculation. Let me do a brief explanation, the meaning of these variables in this formula. First of all, on the left-hand side, you have the FV, future value. So basically, this formula calculates the total account value at maturity of your annuity account in the future. And this D is a deposit amount, the amount of deposit each time, because you make a regular repeating deposit, right? Such as each year, each month, each quarter, and etc. Now, K is annual interest rate. And K, this is the same K that you see in compound interest formula. It represents how many times the account is compounded per year. For example, if it says compounded annually means once a year, right? So K will be equal to 1 if you compound it annually. But if the account is compounded quarterly, so you do it every quarter, right? How many times you compound it per year? That'd be 4 times. In that case, K equals 4. So it's the same as in compound interest formula. Now, I don't know if you notice that or not. It's very interesting here. If you only look at this portion of the formula, D is deposit. If this D become one-time deposit, like that P0, this is exactly the same formula that we use to calculate compound account value in the end, right? This is a compound interest formula, exactly the same. That's why we have this in the annuity future value calculation formula, because annuity account is also a compounding interest account. Only difference that you don't do one-time deposit, you do deposit repeatedly. That's why we have some extra stuff in the formula to account for those repeating deposits. Okay, now N is time in years. Let's see some the example how we use this formula. And this in the beginning, this is the summarization between the difference between a regular compounding interest account and annuity. I already mentioned this in the very beginning. It doesn't harm if we just repeat it once more, right? Annuities assume that you put money in the account on a regular basis. That means repeatedly. Let it sit there earning interest. A compound interest assumes that you put money in the account once and let it sit there earning interest. Compound interest, one deposit. Annuity, many deposits, including withdrawals, as long as it's repeating, as long as it is periodic. It is annuity. Okay, let's look at our first example. A traditional IRA, a traditional individual retirement account, we call it IRA, is a special type of retirement account in which the money you invest is exempt from income taxes until you withdraw. So we don't really care about that part. If you deposit $100 each month into an IRA account earning 6% interest, how much will you have in the account after 20 years? This is the very first example. It is a good time for me to mention the importance that you'll be able to identify what kind of account you have. Because after you learn all of these different accounts, you have all of the different formulas. When you solve a real life problem or homework problem, you have to be able to choose the correct formula to use. And that's a major issue among students when they do their homework. How do you choose the right formula? It depends on if you can identify what kind of account you have in the given problem. So how do you tell that? Actually, there are only three kind of account. Either you have a simple interest account, or you have a compound interest account, or you have an annuity account. Simple interest is very easy to identify because nowhere in the simple interest problem will they mention compound frequency, compound monthly, compound yearly. They never mention that because it's not compounded. And between the compounding interest account and annuity is also very easy to tell because in the annuity account, you have to have repeating deposit or repeating withdrawal to be qualified annuity. So apparently this is an annuity account, right? After you identify that, there's another issue. You have to be able to tell the difference, whether you have a future value of annuity problem or you have a present value of annuity problem. And since this is the first video, we only deal with future value of annuity problem. So it's easy to identify. But when you read it, it can also tell you if you have a future value of annuity. So you make a priority deposit, $100, and they ask you how much you have after 20 years. That's a future value, apparently. And it is an annuity account. You're looking for the future value. So it has to be future value of annuity formula. So I'm going to write down that formula in here just for the convenience. Future value equals single deposit amount times parentheses 1 plus R over K to the power of NK, then minus 1 over R over K. So I just copy this from the previous page. As you can see here, I just copied it in here. Now we are looking for future value. We're looking for this. That means all of the variables on the right-hand side have to be given. So we just need to put the right number into the right place and do the calculation correctly. That will be right. So let's do that. Each time we deposit $100. And let's say this fraction. 1 plus interest rate is always annual rate. And make sure you use the correct K value here. This is a major area people make mistake. So in annuity problem, by default, by convention, this is like a common knowledge in the field that the frequency at which you deposit your money or you withdraw your money is the same as the frequency at which the account is compounded. So in other words, since we deposit monthly, the account will be compounded monthly. The reason for that is very simple. Each time you deposit a certain amount of money into your account, your total principal is increased. So that's a new principal will earn interest. They have to start over to do the calculation of interest each time after each deposit. That's why they compound your account at the same frequency that you deposit your money. So since we do the monthly, k equal to 12. N represent time in years, so that's 20 for us. And k is same k. And make sure this makes sense to you. For the whole year, you get a 6% interest. Since it compounded monthly, we divide by 12, we get 0.5% actually if you do that division. In other words, this part represents how much interest you get per period, per compounding period. Since we compound monthly, this is 0.5%, actually is how much you get per month. Since you do it monthly for 20 years, how many times you do it? 240 times. So each month you get 0.5% and you have 240 months. So hopefully this makes sense to you. And subtract 1. This is just part of formula. Never leave this out. And divided by 6% over 12. These two are always the same. For the annuity, don't worry about how we get this formula because the algebra that is involved during the development of this formula is too complicated. So I chose not to do that. Even though I did the development of formulas for the simple interest account and the compound interest account, but this one is way more complex than that. So we don't do that as long as you can identify which formula to use and you can use it correctly and you'll be fine. So let's do the calculation part. One plus 0.06, change this percent to decimal over 12 to the power of 240, then minus 1, and then 0.06, and over this. Now, another major source of mistake people make when they do their homework is the calculation part. It's a rounding error control. Now, let me make a case here. Say this number is a nice number because 0.06 when you divide by 12, 6 is half of 12, right? You're not going to have countless digits. But that being said, after you have nice decimal number, after you multiply that decimal number 240 times, you will have countless digits, at least several dozen digits. That's minimum. So there's no way you don't round it if you write it down because a calculator can only display like 12, maybe 13 digits, no more than that. So you have to do the rounding if you write it down. Whenever you do rounding, you generate rounding error. And that rounding error, since it's a middle number, when you do other calculations, you will exaggerate that rounding error and it will lose control. So for that reason, we choose not to write down any number if possible. So that's why I like you to look at me closely when I do the calculation, so that we always round our final result. In other words, we only do the rounding at the very end, so that we can control error to be less than 1 cent, no matter how big the amount involved. Okay, I'm going to do this part first, and then after that, I do the division. Then after that, I multiply by 100. So let's do it. 1 plus parentheses 1 plus 0.06 over 12 to the power of 240. Now I'm going to push equal sign to get this result before I minus 1. I just had a student who just have this wrong answer. Eventually, we figure out that's the reason. Because if you subtract one directly, sometimes a calculator just doesn't do what you wanted to do, because all of the calculators are not programmed the same. when they were manufactured. So that's enough to mention the reason we do it this way. So let it to be a number, then subtract 1, then equals. Now, this is the result of this whole bracket on the top. Then I'm ready to do this division. Make sure you use parentheses so that the calculator also follow the order of operations. Divide by parentheses 0.06 over 12 equals. Now I get this whole thing here. Now only thing left is multiply by 100. So I'm going to multiply by 100. This is my final answer. That's an account value after 20 years. 46,204 and 9 cents. You see, I rounded to the second decimal digits for the cents by looking at the third decimal digits. So I rounded up, and this is the final answer. This way, your error is always smaller than 1 cent. So this is just a demonstration how to use this formula. Again, the most important part, identify what kind of problem you have so that you don't choose the wrong formula to begin with. Now this is an exercise problem. I do this as an example. Now you deposit 6,000 into your Roth IRA account at the end of each year, say periodically at the end of each year, same time, same amount, right? How much is your account balance after 30 years? So we're still doing the future value of annuity because we have repeating deposit with fixed amount, and we're looking for the future value of the account. Assuming the return rate is 7% annually, how much interest will you earn? So this time, we have 2 questions to answer, actually 2 questions. One is total account value after 30 years. One is that how much interest we earn after 30 years. So let's get started and write down this formula. Deposit amount 1 plus R over K to the power of NK minus 1 divided by R over K. So we're still looking for this future value. So we plug in these numbers. Future value equals, we deposit 6,000. So 6,000 every year times 1 plus R, we get 7%. The 7% pretty much like S&P 500 index return, like actually a little bit higher than 7% so far on average. Now remember, K is the same frequency at which you deposit your money, right? Since you do it annually each year, your K going to be 1. Your K going to be 1 because the account is also compounded annually. So we have how many years? 30 years. 30 times 1. Yeah. And minus 1 here. This is part of the formula. 7% also on the bottom over 1. Yeah. So now we are ready to do calculation. So equals 6,000 times. I'm going to write it one more time to to make it look neat. 1 plus 0.07 to the power of 30 minus 1 divided by 0.07. We don't need to divide by 1, right? Because it makes no difference. So again, we do this all on calculator without writing down the middle steps. 1 plus 0.07. Again, you don't need to divide by 1. 1 plus 0.07 to the power of 30 equals minus 1 equals, then I divide by the number on the bottom, divided by 0.07 equals, now I multiply by my deposit 6,000 times 6,000. So we get 566K, 66K, 764 and 72 cents. That's total account value. That's total account value. Now, second question, this is question number 1. Now question number 2, we have to calculate total amount of interest earned, right? And we don't use any interest formula because this is not simple compounding interest account. It's not simple interest account. We calculate this from common sense. Since this is your final ending account value, if we subtract your total deposit amount, your own money, anything above the amount you deposit must be from the interest. Otherwise, where those money, the actual money come from, right? So this is common sense. We use your total account value in the end, subtract your total deposit. Make sure you calculate your total deposit correctly. We deposit 6,000 every year. How many years we do that? We do it for 30 years, 180K actually. And that's our deposit. Take this away, the rest must be the interest. So I still have this number in here. I just subtract 6,000 times 30. So we got 380,086. 386,764.72. This is the interest. Actually, you deposit 180K, your interest is more than 380K. Time is money. Time is important. Okay, this is the second one. Now another one. See, we have all of this. This time you deposit 500 into your Roth IRA account. At the end of each month, how much is your account balance after 30 years, assuming you get 7% annually, and how much interest will you earn? If you pay enough attention, you would actually notice that everything is the same. Only thing different is that we deposit 6,000 at the end of each year. If you deposit 500 every month, how much you deposit per year? Still 6,000, exact same amount. You get exactly same amount of time, 30 years, and 7% interest rate, 7% interest rate. So why we have such exercise problem? This is my purpose, actually. I purposely created this kind of exercise problem. Just make sure people understand the impact of time on your money. Even though both 30 years, once that you deposit every month, once that you keep that money until the end of the year, deposit as a one lump sum at the end of each year. Let's say the impact of deposit this month by month versus once a year. So let's do that. Still future value. I don't need to rewrite that formula anymore. Equal deposit amount times 1 plus 7%. We deposit monthly. It will be compounded monthly. We have 30 years times 12 minus 1. So 7% over 12. Again, let's rewrite that. And 500 times 1 plus 0.07 over 12 to the power of 360 minus 1. 0.07 over 12. Now, let's do the calculation. Parentheses 1 plus 0.07 over 12 to the power of 360 equals minus 1 equals divided by parentheses 0.07 over 12 equals times 500 times 500. This is the total amount. 609,985 and 50 cents. That's the account value. Now, let's find the interest, right? Interest using the total final account value, 609,985 and 50 cents minus your total deposit amount. I'm sure this will be the same, but let's just calculate it. 500 each month, and you have 12 months in a year, and you have 30 years of time. This is still 180K. But let's say the interest amount. Again, I still have this total account value on the screen, so I just subtract 500 times 12 months times 30 years equals 429,985.50. Now let's do a quick comparison. And this is a previous page, exact same problem. We just deposit at the end of year with 6,000, or interest, total amount of interest after 30 years, 366K, and this number. Our new interest is this number. I'm going to do a quick subtraction to see the difference. So this is our current interest deposit monthly. Subtract 386, 764.72. Difference of about a little bit more than 43K. We didn't do anything different. You didn't deposit more money into your account. You just deposit every month instead of at the end of the year, but you get 43K more at the end. Why is that? Without numbers, I mean, we have to, this thing has to make sense. Why you get more money? Because by depositing $500 each month, so the compounded monthly instead of yearly, that means every month you get a little bit more interest. You put your money to work for you to earn more interest earlier than waiting until the end of year to make one lump sum deposit every year. So you just put your money into work earlier. So that's the reason. Again, time is money. When you put money into your account more earlier, that means higher compounding frequency. For the same amount, you get more money in the end. Okay, now move on. Exercise. We do all of this as an example. You deposit 1,000 into your account at the end of each quarter. How much is your account balance after 20 years? Assuming the return rate is 8% annually, how much interest will you earn? So nothing fundamentally different, just another set of number so that people have another opportunity to use that formula and make sure students practice enough so that they know how to use the formula, they can do calculation correctly. That's the purpose of I have more exercise using different terms. Okay, do the calculation, future value. We're still looking for the future value. Deposit amount is 1,000 now. And 1 plus interest rate is 8%. Since we compounded quarterly, you deposit each quarter, you will compound it every quarter. This is just annual rate. All interest rates are annual rate in this annuity calculation. So quarterly, we have 20 years of time. So times 4, totally 80 quarters. And 8% over 4. And write it one more time. 1 plus 0.08 over 4 to the power of 80 minus 1, 0.08 over 4. Okay. Parentheses, 1 plus 0.08 over 4. That's correct. To the power of 80 equals minus 1 equals divided by parentheses 0.08 over 4 equals then times deposit amount 1,000. So times 1,000 equals. So the answer is 193,771.96. And that's the total account value. We also need to find the interest. So interest equals total account value. Subtract total deposit. We do 1,000 per quarter, but there are 4 quarters a year. and we do it for 20 years. This total account value minus 1,000 times 4, that's 1 year, times 20, that's for 20 years. So we get 113K 771.96 cents. You can see the total account value is 193K. Your interest is 113K. That means your interest is more than your deposit for sure in this case. Okay, next one, finding the payment amount. Now let me write that formula, rewrite that formula so that we can explain the scenario, new scenario. Say this is the future value of annuity formula. And this is the deposit amount each time. 1 plus R over K, this account is compounding. Minus 1. And this R over K. Now in this formula, first, when you do your homework problem, make sure you identify is the future of annuity account is involved, so that you use this formula. In using this formula, actually, they can only ask you 2 questions, only 2 questions, even though we have multiple different variables. The reason is that they cannot ask you to calculate how many years to accumulate that amount of money, or compounding frequency, or what would be the interest rate in order to reach your goal, all of those, because those kind of question involves a higher level mathematics operations to be able to solve that, like logarithmic operations. And we don't cover that in this course, so they don't ask you anything in here. So they can only ask 2 questions, either future value, given deposit amount. That's what we've been doing from the beginning, right, in this video. Another one is that they give you the future value. They ask you how much you have to deposit each period under these terms to reach your future desired amount. And this is the case. So they can only ask you 2 questions. Now let's take a look at this particular one. You want to have 200K in your account when you retire in 30 years. Apparently this 200K is a number after 30 years, right? That's future value. So you're given future value. Your retirement account earns 8% interest. Look at the question, how they ask this question. How much do you need to deposit each month? That's the most important part. It's not how much do you need to deposit. How much do you need to deposit each month? Repeating deposit, that make it annuity account. Since you're given future value, that's future value of annuity account. That's how you identify which formula to use. So we are looking for this, right? In the future value of annuity account, we are looking for the deposit amount per period. That's D. So let's do that. In other words, we should be given all of these numbers, plug in and solve for D in this equation. Okay, future value is 200K. We are solving for D. 1 plus interest rate is 8%. And you deposit each month, so K is 12. Again, the frequency at which you deposit money is the same frequency that your account is compounded, always. NK is time in years, that's 30, and K is 12. K is 12 minus 1. And we get 8% over 12. Again, I'm going to rewrite this part before we do the calculation. 0.08 over 12 to the power of 360 minus 1, and 0.08 over 12. Now this time our calculation is a little bit different, because in order to solve for D, eventually both sides have to divide by this number. After we do calculation, this is just one number. So we divide by this number on both sides to get a D. So let's do that. So this time I have to write down this number. let's see how I keep the decimal digit. 1 plus 0.08 over 12. Is that right? Make sure that's right. To the power of 360 equals minus 1 equals, then divided by this part on the bottom. So divided by parentheses 0.08 over 12 parentheses. So this number we need to write down. I'm going to write it down. So 200K equals D times this number. And this number is 1490 point. Usually you need to keep at least 6 decimal digits. 359449. Basically, just copy everything on the screen. In your homework for the annuity part, usually the tolerance for your rounding error is about 0.1%. 0.1% of $100,000 is $1. In other words, you can easily round it with have a rounding error that is more than $1, and very easily. But that's for $100,000. If you have something less than that, the tolerant amount even smaller. So that's why you need to keep enough decimal digits to ensure your rounding error is not exceeding 0.1% in the end. And D equals this divided by that. Pretty much like this equation. I assume everybody learned basic algebra, like 10 equals 2x. How do you solve x? You know this is 5 to be right? You divide 2 divided by 2 on both sides. 10 divided by 2 is 5, right? Same thing. But we divide by the number beside your unknown to get this unknown. So 200,000 divided by 1490.359449 equals 200,000 divided by 1490.359449. So we get 134, and rounded to the second decimal digits, basically 20 cents. So you can see that since we have this 30 years of time, since the time is money, as a result, your out-of-pocket money is not that big actually. In order to accumulate 200K, all you need to do is $134 and change, and put it in there every month, like deducted from your paycheck. And if you get this account that pays 8% compounded monthly, after 30 years, you have 200K. So that's this one. Exercise. Basically, everything is the same. We just have different set of numbers, but let's read it first anyway. You want to have this 566K, 765 in your retirement account in 30 years. How much do you need to deposit at the end of each year in order to reach that goal, assuming you get 7% and round to the whole dollar? So basically, we need to find the deposit amount. Still, this is your future value in 30 years, and you deposit every year, that's repeating. So that's annuity, future value of annuity. So we just plug in number directly this time. So you want to have 566K. Let's say how much you have to deposit each year. 765 equals D times 1 plus 7% over 1, because you deposit at the end of each year. That means compounded annually. So you get 30 years times 1. So 0.07 over 1. Let's do this part calculation directly. I don't have enough room left on this page. 765 equals D times. So this is easy calculation actually. 1 plus 0.07 here to the power of 30 equals minus 1 equals, and divided by 0.07 equals, so we write down this number, 94.46078,632. So D equals this future amount divided by this number we just got. So 566,000 and 765. So that's our future value divided by 94.46078,632. Double check. Exactly 6,000. So 500 per month, basically. So you deposit 6,000 at the end of each year for 30 years. If you get a 7% annual return, compounded annually after 30 years, you get a little bit over $500,000. And 7% in the stock market, like a index fund, actual number is higher than this, like 40 some year average is close to 10% actually. Don't underestimate that 3% difference. 3% difference can result in millions difference in the end. Let's one way to the second video about mortgage. Let's talk about the interest rate impact. Slightly different interest rates has a huge impact. Exercise. This is another one, very similar. Let's do that. So again, this is you want to have this amount in 30 years as future value. This time they ask you how much you have to deposit at the end of each month. So this is annuity because repeating deposit. Future value of annuity, you're looking for the deposit amount per month. This the rest are just terms. So future value 609,986 equals D. That's what we are looking for. 1 plus 7% over 12 because deposit every month now. You have 30 years of time and 0.07 over 12. So let's do the calculation. 609,986 equals D times this number. Let's do that. Parentheses 1 plus 0.07 over 12. Yeah, that's this part. To the power of 360 equals. Then minus 1 equals. Then divided by this. Divided by parentheses 0.07 over 12 equals. So 1219 and 970. 996. So we divide by this number on both sides to see what we get. 609,986. Right, divided by 1219.970,996. Yeah, equals 500. So deposited 500 per month and compounded monthly at 7% annual rate. After 30 years, you have almost 610K. That's how we calculate monthly payment in a future value of annuity account. And this is the last one for this video. Yeah, it is the last one. You want to have 47,560 in a college fund in 15 years. How much do you need to deposit semi-annually in order to reach that goal? Assuming that that account have a 8% annual interest rate, we are required to run to the whole dollar for our answer. This is like realistic. Imagine if you have 3 years old, you plan to send that person to college after 15 years, right? And you want to have 47,560. When that person, it's time for that person to go to the college. It's very realistic. This is just a random number, can be any number actually, but this is a scenario. We are looking for how much we have to deposit semi-annually. That means every half year in order to reach that goal under this kind of terms. So again, there's a future value of annuity problem. We're looking for the deposit. So 47,560 equals deposit 1 plus interest rate is 8%. And semi-manually means you compound it every half year. That means you compound it twice a year. So we have 50 years of time. 8% over 2. So let's rewrite it before we do the calculation. D 1 plus 0.08 over 2 to the power of 30 minus 1 and 0.08 over 2. Okay. Parentheses 1 plus 0.08 over 2 to the power of 30 equals minus 1 equals, then divide by parentheses 0.08 over 2 equals, so write down this number, 47,560 equals D times 56.08493775. Yeah, so we just do a simple division now. D equals this number on the left-hand side divided by the number we just got. So 47,560 divided by 56.08493775. $47.999 999. So we rounded 848.00. By the way, they require us to round it to the whole dollar. No, don't bother about this. Whole dollar is 848. So every half year deposit $848, and you got 8% compounded semi-annually after 15 years. You got 47,560. It's not a huge number to go to college in these days, but it's good start for sure. That's it for this one. See you guys in the next video.